Hey everybody, in this video we're going to talk about section 10.2, which goes further with sequences and series with specific ones called arithmetic. So today is all about arithmetic sequences and series. Last time we talked about there are two different types, arithmetic and geometric, and this first one, arithmetic, just think of the first letter A and just think of the first letter A of adding. When you're an arithmetic sequence or series, you're adding the same number from term to term. So arithmetic is also adding. A's and A's helps you remember. All right, that number that you're going to add from term to term is called the difference, which is interesting because we're adding it, but we call it the difference, and sometimes we abbreviate it with the letter D. So for example, if you look at this first sequence we have here, 2, 6, 10, 14, 18, do you notice that from term to term, I'm adding the same number? Can you see what number we're adding from term to term? Yep, it is plus 4 every single time. Adding 4, and adding 4. Therefore, in this sequence, this is an arithmetic sequence, and D equals positive 4. How about another one? This one here, as I go from term to term, you can see that I'm actually subtracting the number 7. But we have to say what I'm adding each time. So really, it's not that I'm subtracting 7, I'm adding a negative 7. I'm adding a negative 7, adding a negative 7. Because you say the word adding, that helps you figure out that the difference is a negative 7. So the difference is not 7, the difference is negative 7. Because it's all the way back here where we said, what are you adding from term to term? Arithmetic is adding, and the D difference is what you are adding from term to term. Okay, well, we've got a really, really important and popular formula here that I'm going to put a big box around and start as well. This helps you find any term that you want in an arithmetic sequence. This will help you find what we call the nth term, n being, again, that subscript that you have there. A is the actual term number, and n is its place in the sequence. Well, here's how we have to do. To find an a-n term, any term in the sequence, you take your first term, a subscript 1, meaning the first term, and you're going to add n minus 1 times d, and d again is the difference that we just learned. So if I want to find the nth term, I take the first term, a sub 1, and I add n minus 1 times d. That's all you need to do. You can use that to find any term, whether it's the 50th term or the 100th term. All you need basically is, again, the first term and the D difference from term to term. So here's how we're going to do it. For example, look at number 1 here. This one says, can you find the formula for the nth term of this arithmetic sequence? Now I tell you it's arithmetic, but could you tell just by looking at it? What am I adding to go from term to term? And I am adding plus 2. So D here is 2. So therefore it is arithmetic. Now these words here, the formula for the nth term is just a fancy phrase, just meaning can you find the a sub n formula up above on the top of the page for this sequence? What's the a sub n formula for this sequence here? 3, 5, and 7. It's also sometimes called the explicit formula using a sub n. All right, well, let's use the formula that I have way up here on the top of the page, friends. We have a sub n equals a sub 1. Well, a sub 1 is your first term. Right here is the 3. 3 plus, and we leave there because we don't know what n is. This is going to be used for any n term that we want. So we leave the n in. N minus 1 times, what was the D difference we said? Right over here, 2. All right, that's a great setup. Why don't we go ahead and simplify this a little bit? So I can take the 3, I can distribute the 2, and I get 2 times n minus 2. So finally, getting our like terms together, a sub n is 2n plus 1. And that is the formula for the nth term. It's almost like a function, where I can plug in a function number such as 5 or 6 for n, and you can give me the actual term number, a sub 5 or a sub n, whatever it is. Let's see if this actually works, because up here, when I have my sequence, 3 is the first term, 5 is the second term, 7 is the third term, and so on and so forth. So if these are my n values, can we check if this formula really works? Let's do it up here. If I knew this was my answer, And I said, well, using that, what is a sub 1? Well, we would plug in 1 for n. 2 times 1, n is 1, plus 1. And that is 3. Hey, that's what we got. What would a sub 2, what would the second term in the sequence be? Using our formula that we found, it'd be 2 times n here, subscript is 2, plus 1. That's 4 plus 1 is 5. And do you see that we're getting the same values out that's actually over here in our sequence? So right now we were just proving that's right. You don't have to do that, but it's kind of neat to see that our answer really does work. So there is the formula for the nth term. Let's try another one. Can you try this one on your own? Pause the video, try it on your own. Let's come back. Again, find the formula for the nth term means can you find the a sub n formula for this arithmetic sequence? Go for it. All right, like before, I did say it was arithmetic, but can we show why? Why is it arithmetic? What am I adding from term to term? How much is d? And if you see, we're subtracting 4, so the d is actually a negative 4, because it's always what I'm adding from term to term. All right, here we go, folks. A sub n, our formula is a1 plus n minus 1 d's. Well, let's see, that would be a sub 1 is my first term. That's 8 plus n, you stay there, minus 1. You said the d difference was a negative 4, so I'll put negative 4 in parentheses just because it looks a little awkward. All right, can we simplify a little bit? How about a sub n is 8 plus negative 4 times n, that's a negative 4n, and then negative 4 times the negative 1 is a plus 4. So again, my final answer when I gather all my terms together, that'd be a negative 4n plus 12. That is my formula for the nth term. And that would give me any term I want in that sequence. What would a sub 3, for example? I know a sub 3 is 0. I know the third term is 0. Let's just check. What would a sub 3 be according to our formula? A sub 3 would be negative 4 times 3 is your n plus 12. And that would be negative 12 plus 12 is 0. So it does work. You got it. And that's how you find the formula for the nth term. Well, what comes back from time to time, especially on standardized tests such as the ACT and SAT, is this idea of puzzle pieces. Where what if I give you different parts of the sequence and you need to get information out of that? For example, on number 1, what if you just know certain parts but you don't know all of it? I do know it's arithmetic, and that's really important. And I know the 8th term is 25 and the 20th term is 61. How could we use that to find, well, a sub 1? How can you use that to find the first term? How can you use that to find the d difference from term to term? And then finally, can you write the a sub n formula when you're done? All right. There's a couple of ways to do this, and there's some very, very algebraic ways to do it too. But let me show you a little bit of a shortcut. I do love this shortcut too. Sometimes I call this the SAT shortcut. All right, I know the 8th term is 25 and the 20th term is 61, which means if these little steps here are all the terms in the sequence, can you imagine that somewhere over here, the 8th term is 25. And somewhere down the line, a little bit farther, the 20th term is 61. So therefore, how did I get from 25 all the way to 61? Can you see how many steps it took? I went from the 8th term to the 20th term. So how many steps is it from the 8th term to the 20th term? You could subtract, and that is 20 steps. Now let's think maybe up here in the big picture. I went from 25 to 61. How far did I travel there? And you can think, oh, okay, 61 minus 25. I traveled a total of 36 total in 12 steps. So if I traveled a distance of 36 in 12 steps, each step was how far? And you can take 36 and divide it by the 12, and you get 3. Well, what does that mean? If every step was 3, what did we just find? And we found D. There we go. So again, what we did is we said, how far did I travel in the big picture from 25 to 61? How far was that? And we did 61 minus 25. But in how many steps? So we looked at the fact it was the 8th term going to the 20th term, and that was 20 minus 8, 12 steps. So I traveled 36 in 12 steps, and that gives me my D value. All right, D is done. I've got D equals 3. I'll put that up here. All right, that's so far so good. Now, how can we go backwards and find A sub 1? Well, the good news about this brand new formula that you found, friends, is you can use it over and over and over again. Watch how. Again, the formula was for arithmetic sequences, it's A sub 1 plus n minus 1 times D. All right, well, I need to find this friend here. I need A sub 1. What did we just found? We found D. All right, well, let's see. Maybe I can use another piece of information to find A sub 1. Well, go back to the beginning. Look at the two pieces of the puzzle they gave you. They gave you either the 8th term or the 20th term. Why don't we plug that into our formula down on the bottom and see if that helps us? I'm going to pick the A sub 8 one because it's just a little bit of a small number. Maybe it'll work out okay. All right, watch how I do this. Okay, I said that A sub 8 is 25. So watch how I plug that in. So 25 is the term number. That equals A sub 1, which I don't know yet, plus, well, what's the n? What's the subscript? What term number is it? It's the 8th term. Remember, A sub 8, A sub n. 8 minus 1, and we said the D difference over on the right side was 3. Just look at what you just wrote. Do you notice there's only one thing to solve for? And it's A sub 1. So now we're just going to do a little bit of algebra here. 25 equals A sub 1. 8 minus 1 is just 7. 7 times 3 is 21. And therefore we can say that A sub 1 is 25 minus 21, or 4. All right, that means this whole sequence started at 4. The 8th term was 25. And the 20th term was 61. That makes sense. Okay, I'll put that up here. A sub 1 equals 4. That makes sense. Now, can we put everything together and can we find the formula for the nth term, just like we did on the previous page? Here we go. Ready? A sub n is A sub 1, which we just found, plus, keep the n when we're finding the formula, times the D difference we said was 3. All right, I'll give you a second to simplify that on your own and check your answer with me. I would get 3n plus 1. And that's my final formula. So we found our D difference. We found that one first. Then we found our A sub 1 by using just the formula. And then we're able to plug everything in. Now watch, I bet you this formula works. Watch. A sub 20 is 61, right? So n is your 20. If you plugged n equals 20 there, what would you get? What would A sub n, A sub 20 equal? And I bet you got 61 back out. So it works. All right, can you try number 2 on your own? This one's same idea. I'm going to give you the second term is 12, and the 6th term is 96. Can you find, again, A sub 1, D, and the formula for the nth term? Go ahead and pause it on your own and come back and we'll talk about it. All right, why don't we try this one? I'm going to erase the visuals here, but see if we can still talk about it without using the visuals, if you remember what steps we took. All right, if you remember, we talked about how big did we travel from one number to the next. So from 12 to 96, I traveled a total distance of 84 between both those terms. In how many steps? The steps were the n values, right? So from the 6th term to the 2nd term, or actually vice versa, from the 2nd term to the 6th term. But I would do 6 minus 2 to get that, and that would be 4. So therefore, total distance I traveled divided by how many steps it took would be 21. And what does that equal? That's our D value. So that means every step we took was equal to 21 overall. Okay, D value, check. Is that what you got? Good. Now let's go back and see if we can find the A sub 1 value, again, just by using the formula. So A sub 1 plus n minus 1 times D. Okay, we're looking at A sub 1. We now have D. And why don't we use one of the two pieces of info they gave us, either A sub 2 or A sub 6. This time, I'm going to actually use A sub 6 just to show you that the big number also works as well as the small number. So I'm going to plug A sub 6 equals 96 in there. Okay, that means 96 is the a sub n number equals a sub 1 I don't know plus what term number is 96? Oh yeah, it's the sixth term. So n is 6 times your d difference from term to term, you're adding 21. All right, and the rest is just algebra here, friends. A sub 1 plus 6 minus 1 is 5. 5 times 21 is 105. That means a sub 1, if we subtract, you actually get a negative number. I believe it's negative 9. All right, that's my first term. And that makes sense because if I'm adding 21 each time, if I add 21 to that, my a sub 2 would actually be 12, which is what I was given. Good. All right, a sub 1, check. Why don't we find the formula, and we'll call it a day on this problem. Here we go. Ready? I'll put it off to the side here. A sub n equals a sub 1 plus n minus 1d, a famous formula. A sub 1 now we know is negative 9 plus. We want the formula, so we keep the n there, and your d difference from term to term was 21. All right, that would be negative 9 plus 21n minus 21. Final answer. My a sub n formula for this sequence, friends, would be 21n minus 30. And that's how that works. How did you do? Did you get the same as I did? If you did, bravo. Good job. And that's problem number 1 and 2. All right, the last thing we're going to do is try to find out how can we add these together. Sometimes you add arithmetic series and you get really big numbers. And sometimes when you have to do it in your head, it's really hard. But the good news is there's a formula here. But now what's really important is this is the sum formula for a finite arithmetic series. If you think about it, if it was infinite series and it was going on forever and ever and ever, we wouldn't be able to add a final sum because it goes too big or too small. It just goes on forever. So arithmetic series, if it's finite, we're good to go. If it's infinite, we can't do it. We're going to find a little bit later that when we talk about the geometric series, there is a way to add an infinite geometric series, and it's pretty cool. We'll find that next time. All right, if I give you an arithmetic series, again, that's a sequence that's being added, and I've got an n number of terms, and I want to find the sum. Here's your formula for this one, friends. And a little helpful key underneath it. S sub n is S for sum, and n for the number of terms. S sub n is the sum of the first n terms, whether it's 10 terms, so it's S sub 10, or 100 would be S sub 100. This formula says n, there's your n again, it's the number of terms, and in parentheses you have a sub 1, which you know is the first term, plus a sub n, which is actually, if you think about it, it's actually the last term. Because if you were finding, say, the first 15 terms, the sum of them, n would be 15. So a sub 1 is the first term, and a sub n would be a sub 15. If you think about it, if there are 15 terms, 15, a sub 15 would be the last term. So a great way to think about it is in this formula you have n number of terms in parentheses times the first plus the last, almost like the bookends. And the last step is we divide by 2. This works. It really does. It's pretty cool. Let's try. Example number 1. Can you find for me the sum of the first 25 terms of this arithmetic series? And you know it's a series because they're all being added. That's a series. Well, gosh, that would take a long time to do it in your head, and even a pretty long time to do it just in the calculator by hand. But hey, we've got a handy-dandy new formula that we can use, friends. Let's do it. All right, first of all, is this arithmetic? I know I said it is, but why? What am I doing from term to term? How much am I adding? My d difference, I'm adding a negative. No, I'm actually adding a positive. D is just 3. Try to confuse you. All right. So there we go. Now, what else do we need? We've got n. N is 25 terms. Okay. How about a sub 1? Do we have a sub 1? Let's see. What's the first term in this series? Oh, it's 11. Okay. How about a sub n? Which here would be, if there's 25 terms, what is a sub 25? Do we know? No, actually we don't because of the dot, dot, dot. We don't know what that is. So we're going to find out a little bit later. A little clue here on the bottom is sometimes you're going to have to step out of the sum formula and go back to the sequence formula to find a sub 25. All right, shall we try it? Okay. Let's go and plug in what we know so far. This is S sub 25, because there's 25 terms, equals n is 25 times a sub 1 is 11 plus the last term, which would be a sub 25, which we don't know, and we're going to find out in just a sec, divided by 2. All right, that's the sum. But you see here, we did get a little stuck over here trying to find a sub 25. Well, let's see if we can find it. Let's use our handy-dandy formula that we learned previously, this one. Because this formula is great at finding any term that you want in the sequence, right? So which term am I looking for? I'm looking for a sub 25. All right, well, let's see if we can find it. That is a sub 1, which is the first term, 11, plus, what's our n value here? You look at the subscript, and it's 25 minus 1. What was the d difference from term to term? It was 3. Look how we have everything that we need. All we got to do is just simplify. A sub 25 is 11 plus 25 minus 1 is 24. 24 times 3, I think, is 72. Therefore, the 25th term is 83. So I stepped out of the sum formula to use the sequence formula from the previous page. And now I'm going to do is, now that I found a sub 25, I'm just going to literally cut and paste and put them back in and simplify. Here we go. Let's give it a try. Now, right where we left off, this should be 25 times 11 plus a sub 25 is 83, all divided by 2. And the rest is just calculator. Ready? 11 plus 83 is 94. 94 times the 25, and then divide your answer by 2. The sum of the first 25 terms is 1,175. Didn't have to do anything in our head. We could just use the formula. So again, important on this one, guys, if you don't know what the last term is, jump out of the sum formula and use the sequence formula to find what you need. All right, last one here. We're going to skip number 3. Don't worry about number 3. Can you try on your own, guys? How about the sum of the first 21 terms of this series here? Make sure it's arithmetic before we use this formula. Good luck. All right, shall we try it? I'm going to need a little bit of room, so I'll open up a new page. This was 2 plus 5 plus 8 plus 11. And I think it was asking for the first 21 terms. All right, so n is 21. So we're looking for S sub, the sum of 21 terms here. The formula says n, which is 21, times the first plus the last. Well, the first term is right here, it's 2, plus, what's the last term? Ooh, that would be right around here. I don't know what that is. What is a sub 21? And again, we don't know. So when that happens, let's step out of the sum formula for a second and see if we can use the sequence formula to help us. So for now, I'll put a sub 21, because I don't know what that is yet. And then the formula says divided by 2. Okay, let's step out of here for a second and have a little chat with the sequence formula. A sub n is a sub 1 plus n minus 1 times d. All right, I'm looking for a sub 21. So how about a 21 equals, the first term, if you remember, is 2, plus n. n here is 21. And the d difference from term to term, well, did we talk about it yet? I don't know if we did. Let's see, from term to term, it looks like I'm adding 3 every time. So that would be my d difference over here. All right, let's simplify that. We get 2 plus 21 minus 1 is 20 times 3 is 60. So the 21st term would be 62. Why don't we just cut and paste and plug them right back in, guys? Here we go. Ready? S sub 21. The sum of 21 terms is 21, 2 plus a sub 21. We found out was 62. All divided by 2. All right, that would be 62 plus 2 times 21 and then divided by 2. The whole thing should equal 672, sorry. And there you go, friends. That's a great start to arithmetic sequences and arithmetic sums. Great job, everybody.